All right, so I split this into two videos because I didn't want it to get too long and you'd get bored and wouldn't want to watch it. So now what I'm going to do is a special case of constant acceleration where we're talking about free fall. This is when you throw something into the air. It doesn't matter if you're throwing it up, if you're throwing it down, or if you're dropping it. All three of those cases are called free fall. In those situations, the acceleration is constant and it's due to gravity. We use the value of gravity as minus 9.8 meters per second squared, where the minus sign, the minus sign refers to the fact that the acceleration is directed towards the surface of the Earth. It's directed downward. And typically, because when we're using 1D motion, we have to assign a positive and a negative direction. And when we do vertical motion, our typical assignments are that going up is positive and going down is negative. Okay? So everything is going to be the values or the expressions that we used in the previous video, the constant acceleration, but now we always have the same value for the acceleration, which is minus 9.8 meters per second squared. So let's look at what our expressions end up looking like for free fall. The other difference that you'll see is because we're talking about free fall, we usually use y. So y, because usually vertical's y, horizontal's x. So y is equal to y naught plus v naught t. And now I'm going to put the minus sign in here, 1/2 gt squared. Oh, I'll do plus because then I'm going to put a negative sign in. In order to not confuse you totally, I'm going to say y is equal to y naught plus v naught t minus 4.9 t squared. So just so we are all clear on the signs, there has to be a negative sign right here because it's gravity and the acceleration is downward. Our velocity expression, which of course we're talking about velocity in the y direction, is v naught minus 9.8 t. So these become, in general, our major expressions for free fall. You might remember in the last video I gave another equation that didn't have time in it, and we can use that as well. For gravity or free fall, it would be v squared minus v naught squared equals minus 2 times 9.8 and then y minus y naught. And so these become the three expressions that we use. And we're going to do very much the same thing that we did previously, in that we're going to be tailoring these to our particular problem. And so I'm going to look at an example and just kind of get these out of the way so we can sort of look at how we might solve a problem like this. In this problem, we have a diver on a diving board, and they're going to bounce on the board, jump up, and then go into the pool. So, it might be nice to sort of draw a little picture of it. So you might have, here's my diving board, here's my person, and they're going to jump up and then just clear the diving board on their way down. And because you're in the air, this is a problem of free fall. The fact that it's a person and not a ball doesn't change the fact that it's free fall. Now, one of the things, they have given me some information, and I might want to put this on my diagram. Take heart. You do not have to be an artist to draw your picture. I've made it this far, and I still draw my pictures, even though they're horrible. So, in any case, we are told that the distance of the board above the pool is 1.8 meters. We're also told that her initial velocity up is 4 meters per second. So let's think about how I can use those pieces of information to make a very specific equations for this particular problem. So I'm going to start first. I'm going to put this pretty far up of y is equal to y naught plus v naught t minus 4.9 t squared. V is v naught minus 9.8 t. So they look a lot like the equations that we used in the previous video, but our acceleration has the value of minus 9.8. And instead of using x for position, we're using y. Now, when we want to put in some of the values for this, one of the things that we have to decide upon is where are we going to say y is 0? You really have two choices. You could say y equals 0 at the surface of the water, or you could make it the diving board. At some point, we will need to use the fact that the distance between the diving board and the water is 1.8 meters, but how your chance that you're getting the problem right does not depend on which you choose for your y equals 0. You can choose whatever you want. It's just then use that reference point properly. I've decided to put y equals 0 at the surface of the water so that y naught is 1.8. We're also told that she had an initial velocity of 4, so I put that in for v naught, and then I have minus 4.9 t squared. For my velocity expression, I have 4 minus 9.8 t. So these are the two expressions that I can use now that are special or specific to this problem. And now I just have to figure out how to use them properly. So this problem is a little bit harder than the one that I gave in the previous video because we have to think a little bit more about how we can use these to help us solve the problem. We're asked to find what is her highest point above the board. So if you think about it, as she goes up in the air, she's going to travel up. At some point, she gets to her highest point, and then she starts coming down. Now, something that you might not have thought about, but as she's going up, her velocity is positive because she's moving upwards. But as she goes down, her velocity is negative because she's going down. So, what does that mean about this point? At her highest point, her velocity is 0. That's really important to realize because that will help us solve the first question here. It says, what is her highest point above the board? Well, that's asking me to find a position value, but in order to find a position value, I need to know the time. But I could find the time, so the time when she's at the highest point is when her velocity is 0. So if I let v equals 0 and I solve for t, I find that the time that I came up with is 0.408 seconds. So that's the time when she gets to the highest point, 0.4 seconds after she jumped off the board. Then I can use that in my y expression to find her y position. And if I do, I find the y position then is 2.62 meters. So I found that at her highest point, she's 2.62 meters. Now, this is where I have to be careful because I said that the water was where y was 0. But the question asked me, what is her highest point above the board? So I need to answer the question, I need to take 2.62 minus the 1.8, because then this will be the delta y from the board to her highest point. And that actually ends up to be 0.816 meters. So she actually only gets 0.8 meters above the board, even though I found this was her position. That was actually the height measured from the water. So I do have to be careful, and I have to think about what I'm doing. So I found that. Now let's go on and solve another one of the questions. I'm going to keep my equations that I use here because I'm still going to use them. I'm just going to erase quickly. The second question asks me, how long are her feet in the air? Again, that's not exactly obvious how I would solve that. So we have to think about, well, what do I know when her feet aren't in the air anymore? In a sense, they're asking, when does she hit the water? And I have to ask myself, what do I know about when she hits the water? I don't know how fast she's going, but because I've let the water be my reference point of y equals 0, I know that she will when she hits the water, y will be 0. So I could use that to find the time. So if I let y equal 0, I need to solve this problem for time. Ugh, it's quadratic. I'm going to rearrange it because I like to look at it this way. I don't like to have the negative sign in front of the t squared. And then I have to use the quadratic formula in order to solve this. Or if you're smart, maybe you have your calculator programmed to solve the quadratic formula. I didn't do that because that would require too much work. I just remember the quadratic formula. So the way that this is going to look is it's going to be, if we think about it's negative b, so it's 4, plus or minus the square root of b squared, which is 16, minus 4ac, all over 2a. And so notice that that gives you two different answers for time. And there are different ways to figure this out. Which should I use? A lot of times one of the values of time is going to be negative, and we don't have negative time. So if we look for the positive value for time, it ends up to be 1.14 seconds. And so that's the amount of time that it took her to get till her feet hit the water. That's the amount of time that her feet are in the air. Then if I want to find her velocity when her feet hit the water, I already know the time. And I use my velocity expression, and I get minus 7.17 meters per second. And that makes total sense because when she hits the water, she's moving downward, so she should have a negative velocity. All right, so hopefully these helped. And hopefully I'll learn to not stand behind my writing too much. And I hope you enjoyed the videos.